Dear students, from our previous classes, it is clear that the tastes and preferences of the consumer can be summarized by the preference relation. Preference relation enables a consumer to rank commodity bundles. And we have stated two assumptions about preference relations to enable a consumer to order or to rank commodity bundles. These assumptions, also known as the axioms, are completeness and transitivity. So, given the preference relation and axioms, it is possible to show that consumers are able to rank all the possible bundles from the least preferred to the most preferred. Now the question is, what is the basis of this ranking? We have stated that a consumer is able to order the bundles from the least preferred to the most preferred if his preferences satisfy completeness and transitivity. But we have not stated the basis of this ranking. Now the question is, what is the basis of this ranking? Now, following the 19th century political theorist Jeremy Bentham, following the 19th century political scientist Jeremy Bentham, economists call this ranking or the basis of ranking utility. The basis of ranking is utility. And utility is nothing but the power of a commodity bundle to satisfy human wants. Or it is simply the want satisfying power of a commodity. So the basis of ranking is utility. And utility is nothing but the want satisfying power of a commodity or a commodity bundle in our case. Now, we also follow Bentham by stating that more desirable situations offer more utility than do less desirable situations. That is, if a person prefers X bundle over Y bundle, if a consumer prefers X bundle over Y bundle, then the utility assigned to the X bundle, UX, must be greater than utility assigned to Y bundle, UY. That is, a person prefers X bundle over Y bundle if and only if the utility obtained from X bundle is greater than the utility obtained from Y bundle. So, the basis of preference is utility, and a person prefers one bundle over another bundle if the utility from that particular bundle exceeds the utility from the other bundle. Now, the classical economists believed that utility is a numeric measure. Classical economists believed that utility is a numeric measure of a person's happiness. That is, classical economists believed that utility is measurable. That is, the pleasure, the happiness obtained from consuming a commodity is quantifiable. That is, cardinal utility concept. So classicals believed that utility is measurable. So naturally, a person's choice of a bundle depends on the quantum of utility he will receive from that bundle. But the problem with this conceptualization of utility is that classical economists were never specific about how to measure utility. They stated that utility is a numeric measure, but they never stated precisely how to measure utility. That is, two issues are here. One is how we are supposed to quantify the utility associated with the different choices. If you choose X bundle over Y bundle, how much utility you will get from X bundle and how much utility you will get from Y bundle. And a second is one person's utility same as another person's utility? If two persons consume a bundle X or a bundle Y, how can you compare the utilities received by person A and person B? So, because of these conceptual problems, economists abandoned the old idea of utility as a measure of happiness. Defining utility as a quantifiable thing is plagued by many problems, as we do not know how to quantify happiness received from consuming a bundle, how to compare utilities of different consumers consuming the same commodity. So, due to these conceptual problems, economists have abandoned the old-fashioned view of utility as a measure of happiness. Instead, the theory of consumer behavior has been reformulated in terms of consumer preferences. Consumer preferences. The theory of consumer behavior has been reformulated in terms of what is known as consumer preferences, and utility is seen only as a way of describing preferences. The theory of consumer behavior is specified in terms of consumer preferences, and utility is only a way of describing preferences. Economists gradually recognized that utility all that matters about utility as far as choice behavior is concerned is whether utility from one bundle is greater than utility from another bundle, and the magnitudes are not important. Magnitudes are not important. Economists gradually came to conclude that all that mattered about utility as far as the choice behavior of the consumer is concerned is whether one bundle has higher utility than another. And how much higher is not important. So, as a theory explaining consumer's choices, if he chooses X bundle over Y bundle, the only thing that is required about utility is whether utility from X is higher than or less than utility from Y. The actual magnitudes are not important. Now, originally, preferences were defined in terms of utility. That is, if utility is measurable, utility is quantifiable, then preferences are measured in terms of utility. That is, if we say that X bundle is preferred over Y bundle, then it means that X bundle has higher utility than Y bundle. That is, utility is the basis of preferences if utility is assumed to be measurable. But now we consider it in the opposite direction. The preferences of the consumer are the fundamental description useful for analyzing choice. That is, choice is analyzed in terms of consumer preferences, and utility is only a way of describing preferences. Initially, preferences were defined in terms of utility. Now it is the other way around. That is, the preferences of the consumers are the basis of choice, and utility is only a way of describing preferences. So nowadays, utility is defined not in terms of not in numerical terms as it was originally conceived by classical theorists. Now, given this concept of utility, let us define what is a utility function. Let us define what is a utility function. Now, a utility function is a way of assigning a number to every possible consumption bundle such that more preferred bundles get larger numbers than less preferred bundles. So utility function is a way of assigning numbers, to every possible consumption bundle such that more preferred bundles get assigned large numbers compared to less preferred bundles. Now, if a bundle X, another bundle Y, suppose two bundles X and Y, then the bundle X, say consisting of X1, X2, Y as Y1, Y2, or simply X1, Y1, X2, Y2, whatever it is. These are quantities of commodities. So, the bundle X is preferred to the bundle Y if and only if utility of X is greater than utility of Y. if and only if ux is greater than uy. So, a utility function is a way of assigning a number to every possible consumption bundle such that, so if x is preferred over y, the number ux will be, that is the number assigned to the bundle x will be greater than, larger than the number assigned to the bundle y, like that. This is how utility is conceived, and this is what utility function is. When we consider just two commodities, then the bundle contain only, say, x1, x2 or x and y. But when we consider many commodities, this can be extended to any number of commodities. And the only property of a utility function assigned is that is the only property of a utility assignment that is important is how it orders or ranks bundles. The size of the utility difference is not important. Size of the utility difference is not important. If x is preferred over y, then the number received to the bundle x must be higher than the number received to the bundle y. The magnitudes, the size is not important. And because of this emphasis on ordering bundles of goods, this kind of utility is known as ordinal utility. Ordinal utility. Because of the emphasis on ordering of goods, this kind of utility is known as ordinal utility. And remember this point. If the preferences, if a consumer prefers x over y, then it simply means that utility from x is higher than utility from the bundle y. The magnitude of the difference is not important. Now, since only the ranking of the bundles matters, there can be no unique way of assigning utilities. As ranking is only important, the assigning of utilities is not unique. Assigning of utilities is not unique means we can assign numbers to utility rankings, but these numbers will not be unique. For example, any set of numbers can be used to assign utility numbers. As an example, if a consumer saying that x is preferred to y, then ux may be 5, uy may be 4. Or ux may be 1000, uy may be 0.5. So, the numbers assigned to bundles, the utility numbers assigned to different bundles is not unique. It is not unique. The only requirement is that the number assigned to x will be greater than the number assigned to y, as long as x is preferred to y. In technical terms, our notion of utility is defined. Listen carefully. Our notion of utility is defined only up to an order. Our notion of utility is defined only up to an order preserving, also known as monotonic transformation. In technical terms, our notion of utility is defined only up to an order preserving or monotonic transformation. And what is a monotonic transformation? A monotonic transformation is a way of transforming one set of numbers into another set of numbers in a way that preserves the order of the numbers. A monotonic transformation is a way of transforming one set of numbers into another set of numbers in a way which preserves the order of the numbers. So, utility function in technical terms is defined only up to an order preserving monotonic transformation. And as such, when we assign utility numbers, it is not important how the numbers, the magnitude of the difference. What is important is whether the numbers preserve the order. As an example, as examples of monotonic transformations, suppose that fu is equal to 3 into u. A utility function multiplied by 3, multiplication by a positive number is a monotonic transformation. Then the order will be preserved. Or fu is equal to u plus 17. A number is added to, a positive number is added. This is also monotonic transformation. Or fu is equal to u square or u cube is monotonic transformation. Monotonic transformation. Now, a monotonic transformation of a utility function is a utility function that represents the same preferences as the original utility function. As an example, if ux and uy are given, and if ux is 5, uy is 4, multiply with 3, it is 15, it is 12. Or add 17 to this, 22 and 21. Or you square this, 25, 16, like that. Monotonic transformation. Order is preserved. So, mathematically, the idea of monotonic transformation is something like this. Any numerical utility ranking, say u, any utility ranking u can be transformed into another set of numbers by the function f. U can be transformed into another set of numbers by the function f, provided that fu is order preserving. And this is ensured as long as f dash u is greater than 0. If the derivative of u is greater than 0, then f is a monotonic transformation. F is a monotonic transformation. All these are examples of monotonic transformation. And in the case of monotonic transformation, if utility function is monotonic, order preserving, it is meaningless to explain this in terms of the size relation between numbers. The only requirement is if a consumer prefers one set over another set, then the number assigned to the preferred set will be greater than the number assigned to the other set. It can be 5 and 2, it can be 10 and 2, it can be 105, any set of numbers. The only requirement is it must be order preserving, monotonic. Monotonic means order, monotonic transformation means order preserving transformation. And the lack of this uniqueness in assigning utility numbers also imply that it is not possible to compare utilities of different people. As there is no unique way of assigning utilities to commodity bundles, then there is no way of comparing the utilities of different persons. It may be that from consuming a bundle X, person A may be getting 5 and person B may be getting 100. B may be getting 100, 5, 100. And who is getting more? We cannot say, because the scales will be different. Stated differently, if utility is ordinal, interpersonal comparison of utility is not possible. Interpersonal comparison of utility is not possible. So remember these points. The basis of ranking is utility. And utility, as we consider today, is ordinal utility, not a cardinal utility. We define a utility function. A utility function is not unique. Is not unique because we cannot assign specific numerical values. The only thing is utility function will be monotonic. Any numbers, any set of numbers can function as utility function. The only requirement is it will be order preserving. That is, if a person prefers one bundle over another, then the number assigned to that bundle will be greater than the number assigned to the second bundle. That is all.